So now today let us start with the deflection of cantilever beam. Right now in front of me I have got a cantilever beam. This is subjected to what? This is subjected to a point load over here. You can see it is subjected to a load of W over here. Okay. So now from our previous discussions we know that M is equal to EI into d square y by dx square. Okay. This is the general equation for moment for the deflection of a cantilever beam. Okay. Now when we are applying for this one, now when you apply the load, what will happen to this beam? This beam will get deflected like this. See? This beam will get deflected like this. So you will have some slope here theta, and then again there is some amount of deflection here y. Okay. Now we need to find out this deflection y as well as theta. Okay. Now at xx, if you take moment, I can write m of x is equal to what? W multiplied by x. Since it is bending it downwards, it is minus sign. Okay. Now let me equate these two. If I equate these two, what I will have? I will have EI into d square y by dx square is equal to minus wx. Okay. Now what I will do? I will integrate this. When once I integrate, I will write integrate. When I integrate, what I get? I get EI is constant. E is Young's modulus, which is the property of the material, and I is what? I is the area moment of inertia. It depends upon the cross section of the beam. Okay. EI into square root of d square y by dx square into dx is equal to, since W is constant, I will take it out, x dx. Okay. So I have this one. So what is the next job for me? The next job for me is to integrate. When I integrate, what do I get? I get EI into dy by dx plus I will get C here, a constant of integration. I will get another constant of integration here. Both of them together I will write on the other side. Okay. This is equal to minus W into x square by 2 plus C1. This C1 is nothing but the summation of the constant of this integral as well as this integral. Is this clear? Now let me apply the boundary conditions. When I will have dy by dx is equal to 0, see, dy by dx is equal to 0 at this point. That is when x becomes is equal to L. Is it not? So now let me write it. When x is equal to L, dy by dx is equal to 0. Now let us apply into that equation. Okay. Then what will happen? 0 is equal to minus WL square by 2 plus C1. Now therefore what will be the value of C1? C1 is equal to WL square by 2. Now if I substitute this one back into my equation, if I call this one as equation number 1. Okay. Now if I put it over here, then what happens? EI into dy by dx is equal to minus wx square by 2 plus wl square by 2. Okay. This is what? This is the equation of the slope. So dy by dx is what? Dy by dx is nothing but slope. Okay. Equation of slope. Right? So now the next one is what? The next one is again I will integrate it. Integrate again. I will write integrate again. If I integrate again, what will happen now? Again EI is constant. EI integral of dy by dx into, here what do I write? I will write it as dx. Again you have a constant here. We will get some constant on that side. We will put together and put on that side. Is equal to minus W by 2 is constant. Square root, integral of x square dx plus w L square by 2 into integral of, what do I say, dx, is it not? I am integrating on both sides. So now what will happen now, if I do this one, I will get ei into y is equal to minus w by 2, here x square was x cube by 3, is it not? W x cube by 3, 3 is here and 2 is here, if you multiply it becomes 6, correct? And then here I will have w L square by 2, integral of dx is what? X, okay? Plus I will have another constant, which is this summation, sum total of all the constants of this and this, okay? Now let us again apply boundary conditions. What are the boundary conditions? When your y will become 0, see here your y will become 0 when your x is becoming equal to L, correct? So now I will come here, y is equal to 0 when